So the volume of a pyramid is 1/3 the volume of a prism with the same base area and the same height. So our formula from yesterday, capital B times H. Today, we're just going to add one thing to it. We're going to add 1/3. Okay, now you can multiply by 1/3 or you can divide by 3 if you want. Either one is fine with me. So B is still the area of the base. So B is still the area of the base. H is the height. Remember, the height of the prism, or the pyramid, doesn't necessarily have to be up and down. Although, for the majority of the time, we will deal with height in a pyramid as up and down. Okay, it should be perpendicular to the base. So, it's basically the same thing we did yesterday, except we're going to divide by 3 at the end. Okay? So find the volume of a regular pyramid. Regular just means all sides are the same. So regular just means all sides are the same. So it's kind of like this one's a square pyramid. So volume here is 1/3 the area of the base times the height. So again, you will get that formula on the quiz next Wednesday. You just have to be able to figure out what goes where. So what's the area of the base if the area is a square that's 14 meters by 14 meters? How do I find the area of a square that's 14 by 14? What do I have to do? Square it. So 14 squared, and the height is 10. So if the base is a square, you're going to do 14 squared times 10. So here's what I do in the calculator. I'm going to do 14 squared times 10. So volume is 1/3 of 1,960, and then I'm going to divide by 3. So you will get some decimal answers in your regular volume. And then our units are always what? Meters cubed. Good. Now, here's the tricky part. In this picture, do you see where the 13 is? Is the 13 the height straight up and down? No, 13 is called the slant height. It's on the side of the pyramid. In order to find the volume, we need the regular height straight up and down to find the volume. So if I redrew half of my pyramid, it would look like this, like my cross section. H, 13, and then this guy down here would be 5, because it would be half the length of the base. So sometimes they give you the slant height. Like, has anybody ever been to Las Vegas? They have a hotel there called the Luxor that's shaped like a pyramid. You wouldn't be able to find the height going straight through that pyramid because it's a hotel. There's a lot of things involved. But you can get the slant height because you can measure the side of the hotel. It would be along the slant height, but you can figure it out. So we can use the slant height to find our regular height sometimes. It's just an extra step. Just like yesterday we had to use trig, you may have to use, this time instead of using trig, I'm going to use Pythagorean theorem. Because I'm given two sides. The only tricky part is, you got to remember you got to cut the bottom part in half. Because we're only using half. We're only using half of the pyramid. So let's do Pythagorean theorem. 5 squared plus h squared gets me 13 squared. This is where, if you remember your Pythagorean triples, it comes in handy. So 5 squared is 25. 169. 144. What's the square root of, anybody know the square root of 144? 12. So the height is 12. Okay, now I can do my volume formula. So extra step. So the volume is 1/3. Now this is still a square base. So even though there's only one number, every side is 10 centimeters. So I'm going to do 10 squared times 12. So I'm going to do 10 squared times 12 divided by 3. So I always multiply the numbers and then I divide by 3 at the very end. So 400 cubic centimeters. Okay, that's one of the harder problems, because we got to take the extra step to do Pythagorean theorem. So if you're ever given the slant height, like see even this one I have here, it's a slant height, 17 centimeters. Question so far. So example 2, it says this pyramid in Mexico is a square-based pyramid with a height of 63 meters and a volume of 970,725 cubic meters. We want to find the side length of the base. So it's a square pyramid, if I can draw it. It gave you the height. We want to find the side length of the base. So volume is 1/3 area of the base times the height. I know the height, I know the volume. So 970,725 equals 1/3 B times 63. What can I do with the 1/3 and the 63? Can I just multiply them? Ew. 21. So 970,725 equals 21B. Then I can just divide both sides by 21. $4,6,225. Okay, but that's the area of the square base. So that's the area, the total area of the bottom of the pyramid. The question says find the side length. What have we been doing since they've all been squares? Haven't we been squaring the side length? So you can think of this as S squared equals 4,6,225 because it's the side length squared. So how do I get rid of a square? And a square root. 215. So each side is 215 meters. Okay. So that's one's kind of tricky. It's not as easy as yesterday. But that's because I'm asking for a specific side length and not just the area of the base or the height. Now a cone has the same relationship with a cylinder as a pyramid does with a cube. The cone is just 1/3 area of the base times the height, so 1/3 pi r squared h. So B is still the area of the base. H is the height. R is the radius. So this slant height that you may see from now on, remember the slant height is like that fancy L, that cursive L. So our area formula for a cone is just 1/3 pi r h. The same formulas as yesterday, just with a third attached. So let's try some cone questions. So here's my cone. Volume is 1/3 pi r squared h. I have h, I have r, so I just can plug it in. So 1/3 pi 10 squared 16. Now it doesn't say exact, so I just do, you can just throw it in the calculator if you want. 1/3, 1/3 pi 10 squared 16. Just make sure when you do a third you use parentheses. Or you can do pi 10 squared 16 and then divide it by 3. Okay, either way, however you want to do it in your calculator. Either way, you get 1,675.52 cubic meters. Now B is trickier. A lot of times we'll throw the weird stuff at you with cones because the formula is so easy. That 9 there, that's the slant height. Do you see how in A there's an arrow that points to the middle? That's how you know it's the regular height. If there's no arrow, it's the slant height. So I can do Pythagorean theorem again. Just realize that your triangle looks like this. The radius is here. This is the slant height. You need the regular height. You don't have to cut it in half because we're just using the radius. If we use the diameter, you'd have to cut the diameter in half. So 4 squared plus h squared equals 9 squared. So 16 h squared 81. 65. Now it's not going to be a nice number. 8.06. Now we can plug it into our volume formula. So 1/3 pi 4 squared 8.06. So pi 4 squared 8.06 divided by 3. So 135.05 cubic feet. Okay, questions? The last one oh, what's missing? I was like, I gave you the height. The radius. We don't have the radius. Do you see how there's a 70-degree angle there? So guess what I'm going to have to do? I'm going to have to do SOHCAHTOA again. So it pops up every once in a while. So this is our 70 degrees. So 25 is which side? Opposite. The radius, which is down here, is what side? Adjacent. So I have to use tan, TOA. So the tan is 70 degrees equals opposite to 25 over r. So if I put this over 1 and I try to cross multiply, I get 25 equals r times the tan of 70. What did we do to both sides when we got that problem? Yeah. R is 25 divided by the tan of 70. So every once in a while you're going to have trig. We did it yesterday when we tried to find the regular height. Oh, I'm not in degree mode. Check, make sure you're in degree mode. 25 divided by the tan of 70 is 9.1. Now we can take 9.1 and 25 and find the volume. So 1/3 pi 9.1 squared times 25. So the hardest part, and you already know how to do this. You've done Pythagorean theorem, we did it at the beginning of the semester, and you've done SOHCAHTOA. So it's just remembering it. So 2,000 centimeters squared, cubed. Like I said, the cone ones seem to be the ones where there's always an issue. Because cones are pretty easy to deal with. Okay, questions on that one? Example 4, we're going to go backwards. The volume of a right cone is 1,350 pi cubic meters. The radius is 18. We got to find the height. So just like what we did yesterday, except we had that 1/3 thrown in there. So 1350 pi equals 1/3 pi 18 squared times h. So what should we do first when we have pi on both sides? Can't I just cancel the pi? So I get 1,350 equals. Now I'm going to take this 18 squared and this 1/3 and simplify it to just one number. So in my calculator I'm going to do 18 squared divided by 3. 108. That way, it's just 108h. So it's just one number. Because now, what can I do to both sides? What can I do to both sides? Divide by 108. So 12.5. 12.5 meters is my height. Just like we did yesterday, like I said, today's really not that different. With the oblique cylinders and the oblique prisms, when you have a cone that's slightly off, or a pyramid that's slightly off, we just use Cavalier's principle, and we're going to do the same thing. Just make sure the height and the base make a 90-degree angle. Okay, so in this cone, even though it's slanted on this side, this is the actual height of the cone, this is the radius. Okay, the height and the radius make a 90-degree angle. So I can use the same formula. So the volume here is 1/3 pi 1.1 squared 2.7. So pi 1.1 squared times 2.7 divided by 3. So 3.42 centimeters cubed. Okay, questions so far? B, what kind of pyramid is that? What's the bottom? What's the base? A triangle. So this is where life gets tricky. We haven't done one yet. So the volume is 1/3 the area of the base times the height. The height of this oblique pyramid, if you can't tell, is this 3 feet right here. That's the height. The base is this 6 feet by 8 feet by 10 foot triangle. It looks like this if you were to redraw it. 6, 8, 10 with a right angle there. So again, how do we find the area of a triangle? Yeah, so we're going to do 1/3, 6 times 8 divided by 2 times 3. Okay, there's a lot of numbers that sometimes they'll give you just to confuse you. We don't use the 10 at all. But we have to cut it in half because it's a triangle. So I'm going to figure out this first. So 1/3, 6 times 8 divided by 2 is 24. So 1/3 of 24 times 3. You should still get 24 because the 3 and the third will cancel out. So 24 cubic feet. Okay, so just make sure if your base is a triangle, you have to divide it in half. Okay, last question. You're making coffee using a cone-shaped filter. It takes 14 minutes to brew the amount of coffee that would be equal to the volume of that filter. Find the flow rate of coffee in cubic inches per minute. Per minute. It takes 14 minutes. So the first thing I'm going to find is the volume of this cone. Then I'm going to divide it by however many minutes it takes. So the volume is 1/3 pi 3 squared times 3.5. Three squared, oops, I forgot pi. Pi 3 squared 3.5 divided by 3. So the volume here is 32.99 cubic inches. Almost 33. It takes 14 minutes to brew through this coffee filter. So if I want cubic inches per minute, I'm going to divide by 14 minutes. Because that's how long it takes the coffee to go through the filter. It's a long time to brew. Just saying. So I get 2.36 cubic inches per minute. That's our flow rate. So you see this a lot. Have you ever emptied a pool or filled up a pool with water? Same kind of situation. You take the volume, take the time it takes. We're going to get to pools at a later date. Questions?